Okay. Hey guys, as you know, I'm preparing for meta interviews. I'm gonna try to tackle this problem and the variants in about 15 to 20 minutes and do like proper explanation, dry run approach, time and space complexities as well. So actually, the question that I'm gonna be tackling today is this one. Okay. So the question is, given the array of integers, numbers, and an integer target, return indices. So we're given an array of integer nums and an integer target. Return the indices of two numbers such that they add up to a target. You may assume that each input would have exactly one solution and may not use the same element twice. Return the answer in any order. Okay. So if suppose I have 2, 7, 2, 6, 7, 11, and 5. This is my array and my target is, let's say, 18. And we see that here at index 2 and 3, output would be. So first question would be actually, we have to return indices. So can we return output format? And this is unique, so we need to worry about size of the input and target as well, range. And also, I forgot to set the timer. Hey Siri, set a timer for 15 minutes. Right, why is she not doing it? Timer for 15 minutes. Okay, yeah. So target range, like what is how from 0 to 1, or its target can be negative as well. Also, are there negative numbers in the input? So for the output format, we can do list of indices that add up. And for the size of the input, it could range from 2 to, let's say, 10 to the power of 4. So avoid space case of just one integer, avoid space of one integer. And target range, what if it was 0? Then I think if there are negative numbers, we should be able to find if anything adds to 0. So the target would be from negative 10 to the power of 9 to positive 10 to the power of 9. Okay, yes. So there could be negative numbers. And for example, this here would be 2 and 3 as the output. Okay. And let's say, and it says that there is, each input would have exactly one solution. Okay, so let's do this. What could be a good approach to solve this? We can have a pointer here and we can check if 2 plus any of the number adds up to the target. So 6 won't, 7. So we'll have another pointer or a for loop that will check for here Does this add? No, 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 no. Then this would set back up to 7, and this would move forward to 6. And again, this will check, does this equal? Does this equal? No. So, right, then it will come back to 11, and this pointer would move forward. And now it will check 7 plus 11 is 18, so it will return the indices. This would be time wise, it would be O of n square, and space would be just O of 1 because we are not adding any additional space here. But we could do like a one pass solution, right? So for this, we can use a complement thing, and we can check that if 2 is at index 0 and its complement would be target minus number. So here it's 16. So 16, does 16 already exist in the array? We don't know that yet, and we can use a data structure like a hash map to store this. So to since 16 has not been seen yet, we can add 2 at index 0. Then we move our pointer forward to 6, 6 at index 1, and we're looking for target is 18 minus 6, which would be 12. 12 exists. No, so just add 6 and 1. And then we move from 7, which is at index 2. We are looking for target 11. It does not exist yet, so we will add a 7 at index 2. Now move on to 11, and that is index 3, and we check, does 7 exist? Yes. So we will just go ahead and return 2 and 3 as our answer. Okay, let me code this up quickly. We're looking at two sum, define two sum, and it will take input as a list of integer, which is array. Actually, it's called nums, and it's gonna give an output of integer, which actually no, it'll give list of integer because it's returning indices. Yeah, and as discussed, we will try to find for I in range len. Actually, for I in enumerate numbers because we need both index and the value. And I think we need index and value. And we also need the hash map. But just use a default date, which is predominantly be because then we don't have to take care of if it does not exist and then it'll give index error. Okay, and then for every number we have, I mean, I could choose a number, and we are looking for complement of that number. So complement is equal to target. Oh, it'll also take in target, which is an integer. Target minus number. And we add this to the hash map. Hash map at complement. Hash map number. That's what we are adding equals I. Actually, we'll check if complement in hash map then just return the hash map at complement and its index, because this is what we'll get as the index, and then otherwise we add hash map at number equals index. And we just return in case nothing would be. Yeah, and the dry run, this is our numbers. So our hash map would be initialized like this, and then we are doing for index number here and enumerate nums. So our num solution that we're using here is 2, 6. So right now when we are at 2, so index is 0 and number is 2. Complement would be target minus, that's 18 minus 2, which would be 16. Nothing is in the hash map. We'll check our hash map is currently empty, so we add a hash map and the number. So number is 2 at index 1, sorry, 0. And then we move forward, and then we come out of this for loop. Now we are at number 6. So 1 and 6. Now we're looking for 18 minus 6 here, which is equal to 12. The hash map does not have it, so this condition does not execute, and we will just append 6 at 1. Then we are at 1, index 2 and 7. We're looking for 18 minus 7, which is equal to 11. Does not exist. This condition would not hold true. And we will add 7 at index 2. This is what it returns. Then we go back up and we are at 11, which is actually its index 3 at 11. Now we are looking for 18 minus 11, which is 7. Is 7, we check if complement and hash map. Here it returns yes, because 7 exists right now. And then we will return just a list as we have discussed before for the output. Hash map at that complement, which is 7, right? And we want to return its index, which is 2. And then the current index that we are at, and that's it. That would be the answer. Yeah, that's all. And how much time do I have left? Oh, one variant could be like, what if we just have to return true, not indices. So we can use a hash set, I think, hash set as, so we just have to return true, not indices, and there could be multiple such pairs. That would mean duplicates in the array. So the example could look like 2, 6, 2, 7, 6, 11, 5, 7, 6. So right now we just have to return true or false. So here if target is, let's say, 9, Actually, 11 plus, let's do one more 11. The target is 11 plus 5, 16. So we can see that like it exists and then output equals true. So we can use the hash set because it wouldn't matter as long as the answer exists, we return true. So we'll put like 2 in there and then we look for complement that have we seen that is 16 minus 2, which we 14, no. Then we add 7 to the hash set and that we'll check for 16 minus 7, which is 9. No, haven't seen that. Then we added 6, so 16 minus 6, which is 10. Haven't seen that, so add that in the set. And this would be like a O of 1 lookup as compared to hash set, which would be, well, it kind of is O of 1, but it could also be O of n if the hash set is like hash function is not good enough. So this could be a variant for that. And then there is one more variant, which is a little different than this. So I can do that in the next video. And we have about 1 minute remaining. So it would be a good idea to do the next variant later. And this could also be like a warm-up question for another set of questions. For example, there is threesome, foursome. So I'll try to go over that in the next videos. All right. And also Pad is what they use. And I need to get like better at drawing stuff out. But I mean, this is from an old question that I was solving. But yeah, we'll figure it out. Thank you for watching. Bye.